This is Lab 5, which discusses the motion of falling objects. And in this lab, we will be dropping a heavy object and a light object and see the rate at which they fall, and ultimately determine how this affects the terminal velocity that the item can reach.
Okay.
Okay, what you just saw was me dropping a stick of deodorant. It went rather quickly, and the height of the door that I dropped it from was about 2 meters. And to estimate my initial conditions for this, I used the mass of the bar deodorant was 0.048 kilograms, and the length of the deodorant was 0.134, which I used to measure the total distance of the door. For initial conditions, the mass of the bar deodorant was 0.048 kilograms, and its length was 0.134 meters. Also, the bar was stationary when I dropped it, so its initial velocity is 0. I also modeled the experiment using VPython. As you can see, my initial conditions are still set, and the time I set was 0.6021 because it fell rather quickly. Also, I ran the experiment twice, once with the B, which is the drag force, and once without the drag force. In this graph, the blue dots represent the bar that I dropped and measured, and the red dots represent the experiment from VPython. As you can see, they look the same because since the object fell quickly, drag force did not play a heavy role on it. This is the model without drag force, and it fits pretty well together. In this model, a drag force was used of 0.015. It was very small and did not affect the model that much. Because the stick of deodorant fell so quickly, it was not long enough for it to reach a terminal velocity. Therefore, the drag force was not enough to match the force of gravity, which is 9.81. This time, a plastic bag was shot from the same position. It had a mass of 0.004 kilograms and a length of 0.2908 meters. It fell at a much slower rate because it was lighter and because of its shape. The initial conditions for this experiment was a mass of 0.004 kilograms. This was plugged into the Python along with the other constants such as the initial position at 2 meters, of velocity of 0 because it was stationary when I dropped it. When I plotted the two sets of data using VPython without a drag force, the results look very different from one another. The blue data represents the results I got from Tracker. As you can see, it appears as an almost straight line because although the force of gravity was acting downwards, the drag force was very large in this case, causing it to fall at a much slower rate. The VPython did not include the drag force, which is why it looks the way it does in the model. When the drag force was added in of 0.065, the model represents each other very closely this time. It looks almost in a straight line, and I calculated a terminal velocity to be 0.777 meters per second. For the object that drops slowly, examine the velocity versus time predicted by your model with and without drag. Which models, if any, predict a terminal velocity? As I said earlier, the first model where I dropped the bar deodorant did not include a terminal velocity because it fell so quickly. It was not a large enough time gap for the speed to become constant. The force of gravity was acting downward, and the drag force did not have a large impact on it. However, with the second model, it was much lighter and therefore fell over a larger time gap. And as you can see by my data points before, it moved in an almost straight line, which suggests that it had reached a certain velocity, a constant velocity. And I calculated that terminal velocity to be 0.777 meters per second. The what-if question states that if the items had been thrown down with an initial velocity instead of dropped from rest, how does this affect the terminal velocity? In the earlier models that I showed, the first ones did not include drag. If there is no drag, the item will not reach a terminal velocity and will continue to be affected by the force of gravity, which is 9.81 meters per second squared. It will keep increasing and not ever reach a terminal velocity. However, in the later models, I did include a drag force, and as you can see in the picture shown, when it is thrown down, it reaches the terminal velocity even quicker. In this model, I use -1 in the y direction. As you can see, it appears as almost a straight line from the very beginning because I sped up the process of reaching a terminal velocity by adding my own force in addition to the force of gravity.